that module 3 is not possible to complete. Okay. That's why whatever you go to discuss in module 3, you go to take into account. Okay.
Yes, sir.
But anyway, module 2 full, module 3, maybe that 4 or 5 lectures is coming, definitely. There's no doubt. Because tomorrow I go to start. This week also I have 2 classes. Next week also I have 2 classes. At least you go to cover some 4 or 5 lectures. So that you go to take into CD2, module 3 also. Okay, anyway, just I go to share the screen first. Just wait, I go to share the screen. Yes, the screen is visible for you. Please check. So lecture 15 is visible. Okay. Yes. Yes. Okay. That is, yeah, the first 1 or 2 slides. That is optoelectronic integrated circuit. That is one small topic. Then you discuss in detail that OLED. That is organic light emitting diodes. So that is your main topic today. That organic light emitting diode. Before that, you see what is the that ICs, integrated circuits, that is up to electronic integrated circuits. Okay. See, basically, whether you know what is the meaning of ICs, integrated circuits or not. Any idea? See, what about IC, integrated circuits? Whether you know or not? No. Okay. Simply go to explain. See, for example, if you go to take the initial, that's for using that vacuum tubes, you know what is the size of the CPU, the first computer, what is the size of the CPU? Any idea? What is the size? CPU size? Anyone? Whether you know or not, that's what I'm asking. No. Say yes or no more.
No, sir.
No, sir.
Okay. Okay. See that the size of the CPU is equivalent to your size of the room. For example, you have the 10 by 10 or 10 by 15 like that, because those days they are using vacuum tubes. Then later, after invention of the transistor, I think you know what is the meaning of transistor. PNP and NPN transistor. Is it correct? I think you studied. Yes? Yes. So after that, you go to see the active and passive components are fabricated in a single chip. We say that is integrated chips, ICs, integrated circuits. So there are so many generations are there. For your first generation, they are using vacuum tubes, and the second, third, fourth generation, they are using the large scale integration and the very large scale. Now they are using VLSI technique, that is very large scale integration technique. And nowadays they are following the AI, that is artificial intelligence. I think you know. Whether you know AI is there or not. What is AI? Yes? I think CSE
Yes,
on subject branch is also there, AI, artificial intelligence. Is it correct? Yes. Okay, nowadays you are using that AI, but anyway, there are so many, this is a law in latest generation now. Okay, so before that you get VLSI technique, that is very large scale integration technique. What is the meaning? That is, you go to fabricate 10 power 5 components per chip. How many components? 10 power 5. That is 1 lakh components per chip. That is a target. That is VLSI technique. That is, they go to reduce. Now, see that those days that the size of your CPU is equivalent to that room, but now the same CPU is equivalent to your packet size. Is it correct? Yes.
Yes, sir.
See that the CPU size is equivalent to this size here. I think how they go to reduce. Okay, that is the technology. That VLSI, now they are taking VLSI, very large scale integration technique. So they go to fabricated that active and passive components. Now, Nowadays, you go to add in that optoelectronic integrated circuit. I think you go to take that optoelectronic component also in the integrated circuits. So that is OEIC. See here. See the active and passive components. That optoelectronic integrated circuit involves the fabrication, monolithic integration of both optical as well as your electronic devices. So electronic, there are so many active and passive components. For example, your transistor, junction diode, UJT, SCR. These are all the active components. So for the resistance, inductance, capacitance, filters, and these are all the passive components like that. So now you go to fabricate both active and passive components in the single chip. In addition to that, you go to take the optical devices also. So that optical devices means you go to take the lasers, the waveguides. So all these things you go to take into account. So that is optoelectronic integrated circuits. That is OEIC. So you go to fabricate optoelectronic as well as the electronic devices in a single chip like that. See, this is an enormous amount of application. There is a numerous applications for this field, different fields for applied science, as engineering and technology. And due to the advantages such as a very high data transmission and very high speed, improved reliability, and very small size, lightweight. So this is the advantages for this optoelectronic integrated circuits. And only the disadvantage is that the process is more complex. Okay, and nowadays this is widely used where in the monolithic fabrication, that is OEIC, the important role where in the case of data processing and data transmission also. So you go to fabricate both active and passive components here. See here, it consists of several active and passive components, and it is monolithically integrated in the same substrate. And these active and passive components are to application for different applications, and all the required voltage. So that is also available in the input voltage or passage of current. And these passive components are also those components which do not require any voltage or any electrical signals. And these both active as well as passive components, the laser, the photo detectors, switches, modulators, these are all the active. And what about your passive? The filters, multiplexer, demultiplexer, and these are all the passive components. And especially for optoelectronics, we are using some lenses also. So you go to fabricate all these things in a single chip here. So that is that OEIC technology, that is optoelectronic integrated circuit technology. And you understand what I'm telling? You say yes or no? Yes?
Yes, sir.
Yes. So
Yes,
this,
sir.
This OIC, you go to see the diagram, I think you understand very clearly. Okay, just wait. I go to show the diagram. Okay. So how that is fabricated each and every one here. See, that is a substrate. So on the substrate, you go to take each and every one on the substrate itself. See here. This is the substrate. The first one is the conventional metal interconnector, lines for power and ground and also the electrical signal. Then after that, you go to see here the optical waveguides or optical signals, that is active components. Then optical signals here, chip to chip, and similarly here the silicon IC chip. Then that metal soldier, these are the metal soldiers, that is also passive components. Then the optical soldiers, active components. So like that, they go to fabricated on a single substrate, please understand. So that optical soldier bumps, that IC integrated chips mounted a multi-chip module substrate. So that a single substrate, they go to take all these things, multi-chip module. So this is the OEIC technology, that is optoelectronics integrated circuits technology. So nowadays this is very familiar. Maybe that is the reason you go to say this is artificial intelligence like that. So that each and every one you get into single chip. All these things available in the single chip here. That's all, very simple. Okay. Understand? No, say on the substrate, see basically you go to take the substrate here more. On the substrate, you go to fabricated that each and every one on the single substrate here. That is single chip. your active components, passive component, that electronic components, all these things available here. See, first I go to take the metal connection for lines, power lines. Then I go to take the normal silicon IC chip, integrated chip. And again, the optical signal chips also I go to connect here. Then optical signals, on chip interaction is also there. And this optical soldier bumps, that is source, detectors, so active and passive components. So all these things fabricated where in a single substrate. Are you understand? So that is the OEIC. That is OEIC. See here. What they go to take? The technology of monolithic integration of electronic components is mature. That is, you go to take the task in the select suitable material, structure, and technology, and which can address the challenges as specified by the new technology and can meet the demands of the communication and computing system. So each and every one is now made up of these OCIC technologies only. They are using this very large scale integration. See, they follow the silicon based VLSI technique, very large scale integration technique. The several optical components on a single substrate is still challenges, but now that also they go to take into account. Okay. Yes. I understand this. Okay, I think this is only the some 3 to 4 slides more. Then you move on to the next our topic is OLED, that is organic light emitting diode. I think normal light emitting diodes last class you discussed. So what is a LED light emitting diode and what is the basic principle? That is a minority carrier injunction. So how the P junction is connected to forward bias, the minority carriers cross the junctions. Okay, that majority cross the junction, they go to act as a minority and they go to recombine with the majority of electrons and holes. You get the light radiation. So that is for normal LEDs, already you discussed. So today you go to see organic light emitting diodes. Organic. So especially this is for the emissive, the electroluminescence here, electroluminescence. Okay, this is made up of thin layers. So the layers is a film of organic compound and will emit light radiation where? To the electrical current, the applied input current. For example, that depends upon the applied input current, they go to emit the light radiation. Here also like electrical energy is converted into light energy, but that process is slightly different compared to the normal LEDs. So this is here the organic layers are there, 2 layers. Okay, that layers can takes place. That electron and hole recombination takes place in between these 2 layers. Okay, I go to explain one by one. First, you go to see what is the basic structure of a OLED. That OLED consists of 6 layers here. Okay, I go to show the diagram. See whether the diagram is visible for you. Please check. Yes. See, there are 6 layers here. I show one more diagram also. First, you go to understand this one. Then I go to show the one more diagram. See here, for example, I simply take the rough diagram here. So there are 6 layers here. See, the first one is top and bottom. I go to see. The top is a seal and bottom one is a substrate. So both are made up of either glass or plastic. Most probably they go to take in the plastics here. See, with the clean glass or plastics. And after that, cathode and anode is there. See here, this is cathode and this is anode here. So cathode and anode layer. In between cathode and anode, 2 more layer is there. That is the very important, that organic layers, emissive and conductive layers. So this is emissive layer and this is conductive layer. Okay, so totally how many layers are there? Seal, cathode, emissive, conductive, anode, substrate. 6 layers are there, 6 layers. And the maximum thickness is see here, that is 100 to 500 nanometer. That optimum they go to take here 70 nanometer thickness. That is a very thin compared to the normal LEDs. See, the normal LEDs is macroscopic, but this is up to microscopic level because the thickness is too small, is order of 100 nanometer only. Okay, and these layers, the 6 layers, I go to show the one more diagram. See here, whether the diagram is visible for you. Check. Yes, the diagram is visible or not? Please check.
Yes,
see, this is cathode. So this is cathode layer. And this see the anode layer, and this is the conductive layer. So both conductive and emittive layer is made up of organic molecules. That is, see here, the layers, organic molecules or some polymers. See here, conductive layer, and this is emissive layer. And next, this is a cathode. On the top of the cathode, you get the seal. I think the seal is not there. Okay. So here the substrate and anode, conductive, emissive, cathode, and one more layer, that is a seal. So there are 6 layers are there. So what is the maximum thickness here? See here, that is order of 100 to 500 nanometer thick. So that is compared to 200 times smaller than our hair, thin hair. See, for example, you go to take your hair. So that the OLED is how many times? 200 times less than that thickness. So such layer that OLED is and most probably the rise they were active. For example, where they go to emit the light radiation means in between that conductive and emissive layers. They can have either 2 layers or 3 layers of organic material. That depends. Okay, and nowadays in the later design, the 3rd layer is also go to take into electron transport. See the transport of electrons, that is charge carriers from cathode to anode or cathode to MC layer like that. Okay, so this is the structure of OLED. I think now you go to understand the structure means. So what is the how many layers are there? Okay, and what are the importance of the each layer? Except you leave it that substrate and seal. The in between 4 the 4 layers. Now I go to explain how that OLED emit light radiation. That is our next concept. Okay. So how I go to, for example, I go to explain one by one. Okay, see here. First, how that OLED emits light radiation. Then you go to see the different types of OLED. See here, first, when the light radiation already I told that is purely that is electrophosphorescence. I think lower classes you studied fluorescence, phosphorescence like that. Are you remember? Yes. So like this is electro. Electro means electrical. That is input is electrical. There is no doubt. And phosphorescence. When the battery or power supply is switched on, okay, of the device connecting the OLED applies the voltage. The current will flow from cathode to anode. Please understand. The current will flow. The current will flow from where? Cathode to anode. Cathode is the negative terminal. Anode is the positive terminal. The current will flow from cathode to anode and through these layers, organic layers. Okay, what happens? I go to explain here. With the help of the diagram, I go to explain. Yes, the diagram is visible, please. Yes? Yes, okay. Now,
Yes,
see,
sir.
carefully listen. How they go to emit the light radiation, I will explain. Please carefully listen. See, this is your layers are there. Yeah? Different layers are there. So different layers. Okay. And the first, when the battery switch on, so conductive first the current will flow from cathode to anode. So that time, please understand, the electrical current flows from cathode to anode. At the same time, the cathode gives electrons to where? Emissive layers. Cathode to anode through the organic layers and giving electrons to emissive layer. Okay, please understand where that cathode current will flow from cathode to anode. At the same time, the cathode gives electrons to emissive layers. Now the emissive layer gets more and more electrons. At the same time, okay, at the same time, just wait 1 second. I mean, class எடுத்துட்டு இருக்கேன் சொல்லுங்க. இது ஓரல் கேளுங்க, ஓரல் கொடுத்தா பண்ணலாம். ஓரல் கேளுங்க, அதான் நீங்க ஓரல் கேளுங்க கொடுத்தாங்கன்னு நம்ம பண்ணலாம். ஓகே ஓகே, வெயிட் பண்ணுங்க, நான் வரேன், நான் பேசுறேன் 11 o'clock மேல. Okay, see the second one, at the same time that anode removing the electrons from the conductive layers. So what is the meaning of removing the electrons? So once the electrons are removed, which one is created? Holes created. Okay, so the equal number of electrons and holes are generated now. Are you understand this? See, the current will flow. The cathode gives electrons to emissive layer. Okay, the anode remove the electrons from the conductive layers. There's no doubt electrons and holes are generated. Is it correct? Are you understand this? Say yes or no. Yes. See, the removing the electrons from the conductive layers and holes, they create holes and that need to be filled with the electrons. How? The next step, these holes jumping from the conductive layer to MCU layer. See here, the holes jumps to the MCU layer, and already in the MCU layer, what happened? Already in the MCU layer, electrons are already there. So simply these holes, they go to recombine with electrons. See, the holes jump to MCU layers and recombine with the electrons. So due to this, that electron hole recombination, a photon of energy, a light energy is coming. Simply, a photon of energy is coming. You say that is a light energy. See here, the light photon is coming. So that electron hole recombination. So this is holes and this is electrons. The holes are in the conductive layer, the electrons are in the MC layer, and these holes jump from conductive layer to MC layer. So simply the electron hole recombination takes place here in between the layers or and the boundaries, exactly at the boundaries. See here, at the boundary between the MC and conductive layers, the electron find electron holes. When the electron finds the electron hole, that recombination takes place here. See, the electron fills the holes, and what happens due to this? The electron gives up the energy in the form of photon of light. So now the OLED emits light radiation. And what about a color combination here? Very, very important. The normal LEDs, I think last class we discussed that the color combination purely depends upon the lambda is equal to HC by EG. Now depends upon the band gap, they go to emit the light radiation. I think last class we discussed. So the gallium phosphorus doped with the nitrogen, gallium phosphorus doped with the zinc oxide. For a different band gap, you see the different colors, blue color, green color, red, like that. What about here? What about here? So the electron hole recombination takes place. They go to emit the light radiation. Everything is okay. But what about the color? That purely depends upon the chemical. What type of organic molecules you go to take into MC layer. See here, the color of the light purely depends upon the type of organic molecules in the MC layer. And the manufacturers place several type of organic layers, and you get the different color combinations. Please understand, different colors you go to get. And the brightness or the intensity of this OLED is purely depends upon the amount of input electrical current applied. Therefore, if you apply more current, you get more bright light. So, and this is more bright compared to normal LEDs. Compared to normal LEDs, that OLED emit more bright radiation also. Are you understand this or not? Please, all of you understand this? So how the light how the light radiation is coming out? That is very simple. See, the cathode, anode, in between the two layers, emissive, conductive. So cathode give the electrons to emissive, anode remove the electrons from conductive. So due to this, the electron hole carrier generation takes place. After that, these holes jumping from conductive to emissive combined with the electrons. So electron hole recombination takes place. Due to this, a photon of energy is coming out. Then you ask a question, sir, that is okay, sir. So what about I get the different colors, sir? That is purely depends upon the molecules I go to take into where? The MC layer. So I go to take different type of molecules, organic molecules. So that is a different type of organic layers, that each layer having the different electrons. When the electron goes to combine with holes, that each layer displays or emit different colors. So that is the basic working concept of organic light emitting diode. That is the reason you put O, organic. That is purely based on the organic molecules. See here, a type of organic molecules in the MC layer. That color is purely, that is the reason you say that is OLED, organic light emitting diode. Organic light emitting. Okay. Yes, organic molecule. Yes, and the output brightness is also purely depends upon your input power. If you give more input power, you get the maximum brightness. Okay. So now you go to see the different type of OLEDs and where you are using in the everyday life. See, I think you give some examples now. What are the OLEDs? I think nowadays we are using.
Yes.
First is your smartphone. First, all the display devices nowadays is made up of only that OLEDs. Is it correct? Yes, yes. Okay, now I go to explain that one by one. What are the different type of OLEDs and where you are using in your everyday life? There are six different types you go to discuss. I go to explain one by one. First, you go to see the passive matrix OLED. So first I go to show the diagram now. Then only I come to see here. So this is a strip. For example, I go to test strip. So cathode strip, anode strip, like that. So the strip, the cathode and the anode made up of strips, and each strip is made up of plastics or glass. Most probably that is made up of plastics. Okay, then both anode and cathode strip is kept at right angles to each other. You go to see the diagram here. See, this is anode strip and this is cathode strip. So both are kept at right angles to each other. Are you understand this? Yes. See here also the anode and cathode. So this is the strip and this is also strip. So maybe one is anode, another one is cathode. So these strips are kept at right angles to each other. Okay, and the each strip is you go to taking as a certain amount of pixels. See, for example, nowadays you go to buy a mobile phone. So simply first you what you go to check the camera. Is it correct? Say yes or no. Then
Yes, sir.
immediately go to check how many pixels are there. What is the meaning of pixels? Okay. You said the 520 or 4 something. Okay, I think you know. I don't know all these things. I think better you know all these things. I think yes. So how you go to take that pixels? See here at each one, the each insertion or that strip, the intersections of cathode and anode make up the pixels where the light is emitted. Okay, please understand. The external circuitry applies the current to select the particular strip of anode and cathode. You get the current that particular amount of pixels are coming and determining the which pixels get turned on and which one is turned off. So that is the passive matrix OLED. Please understand. In the passive matrix OLED, the cathode and anode is in the made of strips. Strips of cathode, organic layers, and strips of anode. And each strip is acting as a pixels of different colors. And how you go to select? See, the brightness of each pixels is directly proportional to the amount of input power. So the only the disadvantage of this passive matrix means it will require more input power, because then only you get the maximum brightness here. See here, the PMLOD are easy to make, but they consume more power compared to other LEDs. More power, because now you go to supply more power here. See, consume more power than other type of LEDs, mainly due to this power needed for external circuit. And the most efficient, for example, all type of text and icons, okay, it can be easily studied with the help of this type of small screen by using this PMLOD. So now you understand where they go to use in the small screen. So small screens means especially for your smartphones, cell phones, and the personal digital assistants, the PDAs. Okay, so the cell phone, the PDAs, and MP3 players all are made up of this type of passive matrix OLEDs. And you understand this? So yes or no?
Sir.
Yes. So this is for small screen. This is for small screen. So what about your large, your computer monitor or your TV screen? Okay. So definitely that is your opposite. You say that is active matrix OLED. That is the next type. AM OLED. That is your next type. So there's no strips. That whole layer, cathode and anode made up of whole layer, but one TFT is there. That is a transistor and filtering circuit. That is a thin film transistor. TFT is there. So that is active matrix. See here, and active matrix OLED. This is a full layer. That is not this a strip. Okay, last time that is a made a strip. Each and everyone has a different strip. But here you go to see the diagram. So that is a whole layer. See here, that is a whole layer, cathode and anode, and in between organic layers are there. Okay, and that MC layer is made up of thin film transistor. So this thin film transistor itself is acting as a pixels, or it goes to determine the how many pixels, which one is turned on and which one is turned off. So there that is made up of strips, So here that is made up of TFTs. So it is a circuitry that determines which pixel turned on and which one is turned off like that. And this required less power compared to that PM OLED. That AM OLEDs consume less power compared to which one? And PM OLEDs. And this is especially for your large screen. Large screen means your TV monitors, say computer monitors, large screen TVs, and electronic signboards or billboards. They are using for this type of AM OLEDs. Yes. So this is especially for the efficient for large display devices. Large display devices. Understand?
Yes, sir.
Yes. I think all these things all in the everyday life you are using here. These nowadays they are available in the market also. I think there's no doubt. Okay. Then third one is transparent. So here except layers, organic layers, at the substrate, anode and cathode are transparent. See here the transparent OLEDs, only the transparent components. Only these, which one? The substrate, cathode, anode. That organic layers is not transparent. Okay. And when this is the turned off, at 80% of transparent to the substrate, and the transparent OLED display in turn on, it allow the light to pass in both active as well as the passive mode, both the direction. That is the reason you go to see either active or passive matrix can be available in the transparent OLED displays. And this is also used for where the head-up display devices, they are using transparent. Okay, this type of, see here, the light rays is coming in the bottom and the light rays is coming in the top. So the next one is either top or bottom. So that is the next type. The fourth type is top. So only the light is coming from the top, substrate to top. So that is your next your OLED. So the top emitting OLED. Okay. So in this case, they are best to suited to active matrix design, and the manufacturer may be used to wear and the top emitting OLED displays in the smart cars. So the light is emitting only in the top portion, not in the bottom. But in the transparent, you go to see here, see the diagrams. You go to take the light in both the directions. Light will come this side also on top and bottoms, both. But in the top emitting, the light will come only where? The one direction, that is top from substrate to that seal. That's all. The light is coming only like this. Yes, and understand this or not? That smart, the smart cards they are using for smart cards here. Smart cards. See, maybe they are using for at least only one direction. One direction.
Sir, what are smart cards, sir?
Your card, yeah, your say that ATM card you are using. Simply they go to, for example, I go to take in the opposite direction. It does not sense. Yes. For example, you are swiping your cards. Okay. So maybe, and they go to take your displays. Maybe at only one direction. Only one direction. Okay. Yes. And the next one is foldable type here. Next, that is foldable OLEDs. That it gives so many advantages here. See, substrate made up of the very flexible. That is material is plastic. Flexible metallic folds or plastics, and these foldable OLEDs are very lightweight and durable, and also where they are using the cell phones as well as the PDAs can to reduce the breakage and the major causes for the return of the repair or something. Okay, potentially this OLEDs display can be attached to the fabrics to create a smart clothing or such as outdoor survival clothing within the integrated computer chips. That is just now I told that organic light emitting diodes, and maybe in the OEIC, that up to electronic integrated circuits, maybe they go to fabricated here for your cell phones and the GP receiver and the OLED display devices and etc. etc. So this is one type, the foldable type. Okay, then the last one is white light MEDs. That is, they go to emit only white lights. They go to emit only white light. So the white light, white OLED means, for example, if you see the batteries, your cell phone, I think you go to use the laser lights. I think that is you say, so only one color, that white light is color coming like this. So like that, you go to take only the white output. So the white OLED emit only the white light that is brighter and more uniform and more efficient than the light emitted by the fluorescent light. So that is the reason nowadays in the buildings, for example, wherever you go to see in the government offices and etc., or for the decorating purpose, and they are using this type of white light OLEDs. OLEDs. So they go to increase where they can be used in the large sheets and they can be replaced all type of fluorescence lights and that are currently used in the homes and the buildings. I think the most of the building the constructed today, they go to decorated house with the help of some OLEDs. So that is pure white light OLEDs. They go to emit white light, but less you go to consume the less power. Less power, you get more brightness, more brightness. So they are used. They could potentially reduce the energy cost for lighting. Are you understand what I'm telling? Say yes or no.
Yes, sir.
I think you see nowadays the new, for example, the new flats or any construction, new constructions, and they are using only the OLEDs, the organic light emitting diodes, especially for this type of white OLEDs. So you less power consumption and more brightness is also there. Okay, understand?
Yes,
Say
sir.
yes or no. Yes. Okay. Then after this, now you go to compare that OLED with LCD and normal LED, and you see what are the advantages. Some disadvantages also there, and what are the applications. See here, the first, I think nowadays there is no LCD. LCD is almost out of date. But anyway, what is the first point here? See, and that OLED is made up of the plastics that is very very lightweight, thinner, lighter, and more flexible than crystalline layers in LED or LCD. Compared to normal LED, LCD, the OLEDs is very, very thinner and lighter and more flexible. So that is the main advantage of these OLEDs. And second one is light brightness. The OLED gives maximum brightness, whether you apply the maximum input power. Okay, see here, because of the organic layers of OLED, you will get much thinner than the corresponding inorganic crystal layers, especially your normal LED. So the conductive and emissive layers of OLED can be multi-layered also. So due to this, you get the maximum brightness compared to normal LEDs. And LEDs, LCDs are requires glass for support, but the OLED does not require glass. That is plastic. Even in the plastic, it is okay. See here, and the glass absorbs some light, but OLED does not require or do not require any glass materials. And one more advantage is backlight. For example, LED, you require the backlight light, but here that is not for. See, the OLED do not require any backlighting like LEDs, and hence they consume much power less than LCD compared to LCDs. And one more, the OLEDs are very easier to produce and it can be made to larger size also. So due to this, the OLEDs are essentially a plastic. They can be made into large and thin sheets, and the weaving angle. So the normal OLEDs have the very large field of view, that is order of 170 degree. That is almost 180 degree off of the angle. Out of 360, it will go to cover. That's why you say the wide range. They produce their own light, and so they can have much wider. So these are all the advantages of OLEDs compared to LED and LCD. But some disadvantages also is there. So main one is the cost. The process is more complex, and the cost wise that is highly expensive. Second, water. So the water can easily damage. I think almost all of you know. Yes. Say yes or no? Yes.
Yes,
So
sir.
these are all the disadvantages. Say the one is a lifetime. The lifetime is compared to other, that is very very small. For example, most of your LED monitors, that LED display devices or LED screen TVs, the maximum they will give the warranty to 2 years. I think, is it correct? Say yes or no? Yes.
Yes, sir.
Maximum. What is the maximum guarantee they will give?
2 years.
2 years. So that is the main disadvantage. See, the lifetime is this order of the 46,000 to the 230,000 hours only. That is very very less. So the blue organics currently have much shorter lifetimes. That is one major disadvantage. And second, the manufacturing process is highly complex and expensive right now, because the LEDs are very highly expensive compared to others. See, the normal heal that neon tube light is 50 rupees and 40 watts bulb. But the same, for example, I go to take LED, so that is only 14 watts, but the cost is 450 rupees. They give 2 years warranty. But anyway, less power consumption, that more you go to save, but anyway, that is expensive. Then water. So water can easily damage these OLEDs. So these are all the disadvantages of that OLEDs. And applications I don't know, because already I explained all these things where they are using nowadays. So OLEDs are using where? The small devices to the large devices, cell phones, PDAs and digital cameras, and several companies nowadays, they are built prototype computer monitors and the large screen TVs. I think nowadays they are available in the market also. So they are using for your OLED devices. Okay. Yes. Understand?
Yes, sir.
Yes. So now you tell me whether any doubts here more that OLEDs. I think first you see what is the structure of OLED, how many layers are there. Then you go each and every layer. I go to see what is the role of each and every layer, substrate and seal, and the cathode anode. That is input, that negative positive layer. Then organic layers. Then how the light is emitting. Okay, that is working concept of OLEDs, and what are the different type of OLEDs available in the market. Okay, then what are the advantages, disadvantages, and applications. So this is a big question here. That is part C type questions, 12 marks. Sometimes they get asking describe and the construction working of OLEDs, and also mention the advantages and like that. So you go to write in all these things, you get 12 marks. So this is a big question. Any doubts or clarification now, please, regarding this topic? Yes?
No, sir.
No. Okay, so then I go to stop the screen. I go to share one more screen. Please wait. So that is also lecture 16. Okay, you go to take the same. Today you go to complete the syllabus for this module 2. Okay, that the problems related to this topic. Yeah, the problems related to this topic. That is only one problem. That is a single formula only. Okay, that is by using only one formula, you go to use the problems here. Okay, see lecture number 16. So you go to calculate wavelength or energy gap. Okay, the data are given. So by using the data, you go to calculate the wavelength or energy gap. So that is the only formula using the problems here, the 5 problems. See here, determine the wavelength of the radiation given out by the LED. The energy gap is given. So the energy of 3 electron volt. And the H and C values are, see, most of the problems, they don't give H and C values. Please understand. H is Planck's constant and C is velocity of light. They don't give the values. Please, you remember that values. So only the band gap they will give. Okay. See the energy of 3 electron volts, EV, in terms of EV they will give. So now what is the formula here? That E is equal to H, that is equal to HC by lambda, or I go to rearrange the formula. Lambda is equal to HC by EG. So that EG is nothing but the energy gap between the layers. So here that is E. And they are given H value, you substitute C value, and E is in terms of electron volt they are given. You convert it into joules by multiplying 1.6 into 10 power minus 19. So you get the value that is 440 nanometer. Please, all of you go to check and confirm so whether this is correct or not. Okay. So anyway, that is correct. That is in the visible range. This is in the visible range. That is 440 nanometer. At 400 to 700, I think you know that is in the visible region. So maybe this is for your blue color or something. Okay. So that is LED, blue color LEDs. Understand? Yes. See, I think all the problems related to this only one formula only more. See here, next one, I think same. And calculate the wavelength of light. This is gallium arsenide. This is gallium arsenide whose band gap is 1.44 EV. So they are using that LED made up of gallium arsenide. You go to see what is the wavelength. So simply that wavelength is HC by EG. So you go to substitute H, C, and the energy gap is here 1.44, convert into electron volt to joules. Then you see what is the answer here. That is 8,000 angstrom unit. I think this is not visible. 400 to 7 beyond the visible range. Maybe that is infrared or ultraviolet like that. Infrared region. So 8,628 angstrom unit. So this is your problem number 2. And 3, again they using the same. So calculate the long wavelength and limit of the extrinsic semiconductor. And the ionization energy is given. That is 0.02 electron volt. Again, you go to substitute the values here and tell me. So what is that? Is 6.2 into 10 power minus 5 meter. That is very large. That is order of 62,000. I think you go to take 4 more digits. 62,119 nanometer. So that is very long wavelength side. Very long wavelength side. So that's why they mentioned the question. Calculate the long wavelength limit of the extrinsic semiconductor if the ionization energy is 0.02 eV, like that. Understand? Say yes or no. See whether you understand the problems or not.
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
And 2 more problems they are given. You do it yourself. See? Okay. So the LED as a peak emission of wavelength is given now. So now instead of band gap, they will give the wavelength here 1.55 into 10 power minus 6 meter. So now you go to calculate band gap in terms of EV. So the formula is the EG is equal to HC by lambda. So you substitute all the values HC lambda. You go to find out. So that is energy gap in terms of joules. So now you go to convert. How you go to convert? Simply divided 1.6 into 10 power minus 19. So you get energy gap in terms of EV, electron volt. Okay. So at least next class you go to confirm the answers. What is the answer for this 4th and 5th one? Okay. I think 5th one is also similar to this one. The cadmium sulfide energy gap is given and wavelength is given. You go to calculate the total energy falling on the surface and check whether the electron hole recombination takes place or not, like that. Okay, this you go to do it yourself. You get some ideas. Then only you get some ideas. Okay. Understand?
Yes, sir.
Say yes or no, whether you understand or not.
Yes, sir.
Yes,
Okay,
sir.
so this lecture 16 is a problems related to this topic, the 13, 14, 15 lectures. So in the 13, 14, 15, you discuss only LEDs. Okay. So by using that formula, that only this formula only, you go to see these type of problems here. That's all. I think lecture 10, there is no problem related to the topics that lecture number 7, that the 8, 9. Okay, lecture 10 is not there. That's why you don't take that lecture 10. Okay, lecture 4 is problems that I will go to upload. Okay, I think already we discussed. That is a problem related to the topics. Okay. Yes?
Okay, sir.
Okay, so now I think I go to stop the share screen. You please wait. So that module 2, I think now you go to complete the module 2. Okay. So the module 2 is completed now. Tomorrow, at least you go to take module 3. That is next module you go to start immediately because you are facing CT3 now, falls on next week. So now, so after this, I go to entered. For example, I go to upload your question bank as well as full notes for this module 2 also in today or tomorrow. No problem.
Sir, when is CT2?
December 4th, I think next Friday. Coming Friday is 27th. Yeah, I think. No, both MCQ and descriptive both are there. This time MCQ and descriptive. I think both, because this time you get 1.5 hour exam. So 9 to 10:30 you have exam. So definitely objective type as well as descriptive type is also coming. The descriptive type you go to write the answer in the A4 sheets and go to scan and immediately go to upload. That is the process they will take.
So is it
How
short
many
answers or
questions,
long
sir?
answers?
Most probably short answer or that is not discussed more. That they will discuss. Okay, they will announce maybe 1 or 2 days. So
Okay,
definitely they will tell what is the question paper pattern and maximum 50 marks they go to conduct the test. I think most probably the 31 CQ is there and Descriptive type, maybe 3 marks or 4 mark questions are also there. I think 10 3 mark questions or 5 4 mark questions, like that they will inform. Anyway, they will tell, you just wait, you will wait. They will give the circular. I think they will send the circular. So otherwise, in the class committee meeting, you will discuss what type of question papers you go to select, like that. MCQ, descriptive, both are there, no doubt. Okay. Yes, say yes or no.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, Nikhil. So what about I think 70 is there, yeah, strength 69. I think only 2 or 3 students are absent. Okay, anyway, I quickly take the attendance. Please give your attendance now. Okay, please don't leave. After giving the attendance, only go to leave. Please wait. So quickly I go to take the attendance.